I'm Brian Orr with the HVAC School Podcast and HVACRschool.com, and this morning I'm headed out to work on a refrigeration unit for a customer. This unit's been having some issues with defrost intermittently, so they've unloaded it, and they've got a whole bunch of meat coming in that they want to load into it, so I need to make sure that it's working properly. So it was a perfect situation for using the new Danfoss ERC 213. The ERC 213 is especially great when you have a situation where somebody has an old school mechanical control and they want a little more precision, a little more accuracy, and a little more reliability, as well as a lot of additional options that you get with the ERC 213. So we're gonna head out and take a look at that. All right. Jeff's here, Max is here. Morning, Max. Morning. The goats are here. How's it goating? All right, so here's what we've got. Reach-in freezer. This one actually already has a digital control, but we have reason to believe that it's got intermittent issues. In fact, when I showed up here, it was going in and out of defrost like crazy. So that's the issue that we had previously when it was loaded full of meat. And so they just took it out of commission for a season, and instead of messing around with it, we're going to go ahead and just put in the Danfoss 213. But again, one of the really good applications for the 213 is to use it even in cases where there may not be an issue, just because you want an efficiency upgrade, a reliability upgrade on the control. So here we go. All right, so this is the Danfoss ERC 213 kit. It is a universal refrigeration controller kit. It comes with a quick start guide, comes with the controller itself, and then it also comes with these two temperature sensors. Most typical applications, one of these sensors would be for the box temperature or air temperature, and then the other sensor would be for the coil temperature or defrost. So if you look at the controller, the face of the controller, you've got a couple multifunction keys. You've got like a selection button that scrolls through. You've got your set button, which this is what you'd hold in to actually set your set point or make adjustments. So you hold that down for 3 seconds. Then you have a multifunction up or down. If you hold this button here, you can see it looks like a snowflake dripping. That's defrost. If you hold that down for 3 seconds, it'll go into defrost, and then you have power on and off as well. You'll notice a couple things here. It's got these depth adjustments on it that slide in and out. It's very nice. You just hold down this little button, I guess, right here on both sides, same thing. You have all of your terminals connecting to the back. These are your high voltage terminals, you can tell, larger gauge, and then you have your smaller terminals, which are like your temperature sensors. You can see here you've got your compressor control. This is the highest amperage rated. So if you look here, you have 16 full load amps on relay DO1, which is this one here. You have a rating of 8 amps on DO2, which is this switch right here, and then you have a rating of 3 amps on DO3, which is this one right here. If you look closely here, you can actually see that there's a little icon here. This one here is an icon for a compressor. This one here has an icon of defrost, and this one here has a fan icon. So that's generally how this would be set up. Compressor, defrost, and fan. But you do have some alternate options. And then you have your air temperature sensor that connects in between these points. And then you have your S5 sensor, which is your coil sensor, your defrost sensor right there. But this is sort of your standard wiring. You'll notice that, again, you have larger gauge connections here, but a key thing whenever making high voltage connections is that you want to make sure that you strip the wire back the right length. Also, not a bad idea if you have the time to do it or you're willing to do it, if you want to tin the ends of the wires. That can kind of help keep all the strands together on a stranded conductor. But another thing you'll notice here is you have your 115 volt inputs in between these 2 points. If you look here, you'll see that there's an embossing. Is that how you say that? It's embossed on here. You have line and neutrals. One really nice thing about the ERC 213 is that it comes with an easy quick start guide, which goes through some of the most common applications that you're going to set up with this, and it really walks you through one at a time how to set it up. So you really just a matter of following the instructions. And then if you see, it has these control application codes, which they call apps. So you're actually selecting an application. And then from there, you can make your final adjustments. But it's easier if you start with one of their one of their applications versus the universal ones, which would be app 0 and app 6. In other words, if you start with app 0 or app 6, you're basically starting with a blank slate. Otherwise, you can start with refrigeration with natural defrost, refrigeration with electric defrost, a freezer with electric defrost, refrigerator with electric defrost, 2 temperature sensors, freezing with electric defrost, 2 temperature sensors. So it gives you that option of choosing time and temperature or just time and what type of defrost you're using in essence. You'll also notice here it explains all the different buttons and what they do, which you can definitely go through. First time you start one up, make sure that you understand all the different functions. So you can see it shows you the same thing. This is the same diagram that's on the top of the ERC 213 itself, but you can see here that it also better defines each sensor. So your S-Air is your control sensor, your air sensor, your defrost evaporator sensor, SC is a condenser sensor. You have a couple digital inputs here on DL1 and DL2. So DL1 and DL2 in between 12, 13, and 14. You'll notice that 8 and 7 don't currently show any purpose with this programming configuration. The app sets all of these parameters to predefined settings, but if you want to go through and adjust all the parameters, that's also in the Quick Start Guide. Also in the Quick Guide, it shows you how to set up for different sensor resistances. And so if you're using the ones that come with the kit, you have a NTC, negative temperature coefficient, 10,000 ohm resistor, and you would use code N10 in the sensor section. But you can use any of these codes in order to set up the standard types of sensors that you'll often see in refrigeration. Really, this covers all of the standard types of sensors. The Quick Start Guide also shows you some typical wiring configurations depending on the app that you've used. So in essence, once you figure out your application, you go and wire it the way one of these diagrams show you, which are the standard, most typical types, and then you choose the application to suit. Another thing to notice is that on the DO1 compressor relay, it does have a rating also for a 230 volt compressor, if that's how you have it wired up, depending on whether of course you're using a solenoid or whether you're directly running the compressor off of it, is going to be dictated by the particular situation that you have. But you need to make sure that you don't go above the 10 full load amps or 60 lock rotor amps if you're using 230, and it's 16 full load amps and 72 lock rotor amps if you're at 115 volts. So now, just for demonstration purposes, I'm going to go ahead and wire this up to 115 volts. I have tinned the ends of these wires just to kind of hold all the strands together and make it especially safe, since I'm using a piece of lamp cord here. One to the left side of the low voltage block is the air sensor, but be careful because you do have 1, 2, 3, 4, 5, 6, 7. Which is 1, 2, 3, 4, 5, 6, 7. So it's actually these two here that we're using for our air sensor, which I'm going to just wire in. I'm going to just tighten down the left one to start with, because I have to wire in the other sensor and share the common. So you can see it's measuring 77 degrees Fahrenheit, and that is about exactly what it is in this room right now. I'm showing 76 degrees on my thermostat right now. So let's go ahead and set up our typical configuration following the quick configuration mode. So first thing I do is I press this for more than 3 seconds to enter the quick configuration mode. And now I have the 061 that appears on the screen just like it says. Then I press set while the 061 is on the screen, and that lets me choose my app, which is currently at AP0, which is the default. Then if I want to press up and down, I can select the different app modes. So AP1 would be refrigeration, natural defrost, 1 sensor. This would be refrigeration with electric defrost, 1 sensor. But let's go ahead and do a freezer with a temperature defrost. So that would be 5. That means we use 2 sensors, air sensor and a coil sensor, and then the default is minus 11 degrees with a temperature range min max 15 to 4. Default differential 4, defrost interval an hour, 6 hour defrost interval, max defrost time 30 minutes, and defrost termination temperature at 43 degrees. So once you have it set in how you want it, then you just hit set, and now it will just display that for a little bit, and then it will reset on its own. Now it's set. See all of these. Every single one of these little crimp connections are cracked. Every single one. And then when you look down at the connections to the compressor contactor slash relay, all of them are just melted. So we're going to remake all these. Put in a new relay. The one thing in this particular case is you have to remember that your compressor contacts, these can be either 115 volts or 230, which is why they make them dry contacts. So it's not actually pulling from the 120 volt feed. So you have to bring in a separate 120 volt feed wire to feed the compressor. And in this particular case, they are using the same power feed for the compressor and all of them, because of course it's independently controlled by a contactor at the bottom. So we're going to have to bring a wire from the hot, which if you look down here, you can see line and neutral here. So you have to bring a wire from line, and actually I'm going to splice it further down, from line into your feed on the compressor, which would be this right here, this terminal right here, which is terminal number 2. So the way it shows it, it doesn't really matter because it's dry contacts. You could cook the compressor on either side, but you have to bring power into one of these terminals and then the other side out to the compressor. If that makes sense. Whereas on the fan and the heater, it's fed from the power that you feed the control with. Okay. So one of the things that I always like to do is find potential causes for problems. And when you have all these burned up wires and everything, you kind of ask, why? We have a hard start kit. It all looks to be in good shape. I don't see any issues there. And again, we'll test it further once we get it running. But we had a run capacitor on this thing, and I have some very good friends in refrigeration who tell me that the run capacitors never fail in refrigeration. But we are in Florida. We have higher temperatures, and so it does increase the odds that you do have failures. And so I'll show you what I got here. We are running 3.9 microfarads, and we are rated at 30 microfarads. So when you have a hard start kit in place, this isn't, it's a start capacitor and potential relay. What'll happen if your run capacitor isn't working well, then your compressor will ramp up, get to 80% speed, the potential relay will open, the start capacitor will come out, and if the run cap isn't functioning properly, that motor can start to wind down again and hit the point that once again the potential relay kicks in, and it just keeps bouncing back and forth in inrush current, which can definitely result in what we're seeing here. Not saying that is the cause, but on a freezer that we knew was working, it makes a lot of sense. So it's not like we had a freezer that wasn't working at all, but it did have some intermittent issues. It makes a lot of sense that this could very well be part of the cause, as well as all this burnt up mess we've got. I'm demonstrating how to wire this up, just proving that it's going to work before I put it all in place, and I did the thing that I just mentioned not to do. I made the mistake of using terminal 8 for the sensor, which is actually an unused terminal. So that's one thing to remember when you're wiring these up, because it's just easy to go all the way to the edge. You got to come in one. These are the 9, 10, and 11 are the sensors, and also the same thing if you're working from the other side, number 7 is an unused terminal as well. So in essence, I wired it wrong. Alright, so we ran into a very interesting circumstance here, which is that this particular reach-in actually switches the neutral side of all the circuits. And as you see here, we have a these are dry contacts for the compressor, because you can use either 120 volts or 240 volts, 115 or 230. But for the defrost and for the fan, it actually passes through power from your line side in order to power the fan and the defrost. And so if you look here, you got line and neutral. And so what I wasn't sure about is if the control would work if you swapped line and neutral on the control. So the first thing I looked for was there any, you know, metal body on this? Is there any grounding, anything? And there isn't. It's all plastic. So I went ahead and powered it up and just swapped over line and neutral just to see if it would still work, and it actually does. Everything still works properly. Sensors all work, controls all work. And then I tested to make sure that instead of passing hot through, it was passing neutral in order to work with this particular application. And sure enough, it works just fine. So not saying that that's something that you'll do normally, and it's not really even the way that I would like to see it work, but in this circumstance, that's what we had to do in order to use this control, and it actually works fine. I always make sure that my wires are just as long as they need to be and no longer, so that way I don't have any bare wire hanging out the back and short out. You can see here this little symbol. It's got a little bell, and then it's got a defrost symbol as well. So it's either an alarm or defrost is what those contacts are generally used for. And then we connect in our power. Now in this case, I'm actually swapping the polarity because this freezer is wired up to break neutral. But in general, you would put line, so in this case black, on this side, but I'm going to swap it. Alright, so we got it together, and I thought that I had the sensor set right, but apparently I didn't. So we're going to go in and set the proper temperature sensor. One thing that I noticed pretty quick as I'm trying to test defrost is that if you try to force defrost too quick, it doesn't go into defrost. It won't force it. So normally if you hold this down for 3 seconds, that can both initiate and terminate defrost. But the reason for that, Max pointed out here, is it has something called defrost. So if you look at the troubleshooting guide, it'll say defrost does not start, and the controller's in pull down mode. And so it has a duration where initially it's not going to allow defrost even during the typical time because it needs to make sure that it pulls down. Yeah, I don't always wear white linen pants. Okay, so first thing is setting up the sensor. We had to go in and do that initially, and I ended up just changing the sensor because the original sensor was a little erratic. So in order to do that, the first thing is you need to do the install setup within a minute of operation initially powering it on. So you can see right now it's not doing anything. So in order to do it again, you can just power it off, and you just hold down the button until it goes off. Give it a little bit of off time so that way it doesn't short cycle. Here's a good time to play some snazzy tunes and speed up the video really fast. Now to go into our base app settings, just hold that down and then hit set. So we're in app 5, and the reason we're in app 5 is because app 5 is freezing with electric defrost, 2 sensors, meaning we have both time and temperature. Default temperature -11, temperature range -15 to -4, typical settings. Default differential 4 degrees, defrost intervals every 6 hours, which is 4 defrosts, max defrost time 30 minutes, and defrost termination temperature at 43 degrees. So all pretty typical things. We can change the number of defrosts. Like I want to change the number of defrosts to every 4 hours because we're in a very high humidity environment here in Florida. So I'll make that adjustment. We can make that adjustment in the additional parameters. But then also what I want to show you on this display here is that if you hit set again, hit it twice, then you're in your type of thermistor. So you can do a negative temperature coefficient 5K, negative temperature coefficient 10K, positive temperature coefficient, and so the difference there, I'll show you what they are because I don't remember them off the top of my head, but you have PTC, PTC 1000, NTC, and NTC 5000. In this particular case, I've installed the factory one now because I installed the one that comes with the Danfoss ERC 213 kit, as opposed to using the one that came with the freezer, because the one that came with the freezer was acting up. So I'm going to go ahead and set that to N10, which is the one that the factory sends, and then just hit set, And then once that's done, it'll do a quick reset. Alright, so it's now a few days later. I'm just coming back and checking on this freezer. I haven't opened it yet, but it did just come out of a defrost. So we're doing pretty good shape. We're going to be loading this full of product in a couple days, or we're not going to be, the customer's going to be. You can see this is in a unconditioned space. This is just like a warehouse, uninsulated warehouse. We're in Florida, and we've been having a lot of rain, so our relative humidity is extremely high. So this is not the ideal condition for this freezer to be in, because you can see all the sweating, and there's nothing we can really do about that. So unlike the quick startup menu, to go in and set the full parameters, you actually do that. You don't have to do that within the first couple minutes of power up. You can do that at any time. So with the quick startup menu, you hold down this button here for 3 minutes, but once you want to set the full parameters, you hold down set for 3 seconds, and then it'll say IN, and then you cycle through whichever parameter set you want to go into, so the first letter. And so we're going to go through and just check the defrost settings just to make sure everything is set in how we want it for this particular freezer. So once we get into D, we're going to hit set, and now we can go through our parameters. So D2 is the first one. D2 is to set whether or not it's Fahrenheit or Celsius, which we know we're already Fahrenheit. D3 is defrost interval. So let's take a look and see what we've got at defrost interval. So we've got a defrost interval of 4. That's a 4-hour interval, which gives us 6 defrosts per day. I'm doing that because we're in Florida and we have this super humid environment that this is in. I just want to be safe, make sure that we have enough defrost. So that's our defrost interval. And so you can see I'm just toggling back and forth between set and the up and down arrows. It's pretty simple. Yeah, so we actually cycled off not too long after a defrost, so we are doing okay even given these conditions. So we live in a world today where we're expected to do more and more calls in a day. We're expected to get it right the first time. Our customers don't understand that we have to come back and adjust a setting or recheck over and over again. So we really need to be able to get it right the first time. And with older mechanical controls, you know that the accuracy can be 2 or 3 degrees off. You don't have all these defrost capabilities. The ERC 213 is a great solution to replace those controls with something that you can be confident is going to work. If you want to find more about this control, you can go to danfoss.com. Thanks for watching.